Hello everyone, today we will be talking about angles and triangles. We're going to start with angles. Angles are created by lines that intersect. So here I have the two lines that intersect. They create 1, 2, 3, and 4 angles. The angle shows us basically how open or closed the lines are for the area that we're looking at, basically for the angle that we're looking at. So here, the red one shows that they're pretty closed, but if I look at the orange one, they seem pretty open. It depends on where I look. Angles can be separated into types based on how big or small they are. We're going to start with the simplest kind, which is a right angle. A right angle is created by two lines that intersect and make a cross. When this happens, I put a little square here to show that this makes a right angle. When this happens, a right angle is always 90 degrees. Degrees are how I measure how open or closed an angle is, and a right angle is always 90 degrees. Next, I have angles that are smaller than right angles. So here, for example, if I look here, I have an angle that, as you can obviously see, is less closed than this one. This one is much more closed. It's smaller in comparison to a right angle. And what that means is that since this one is 90 degrees and this one is smaller, it always has to be less than 90. We call these kinds of angles acute. And lastly, we have the ones that are more than 90 degrees. We call these, as you can see here, this is obviously more open than the right angle. It's bigger. So what that means is that this has to be, more than 90 degrees. We call these kinds of angles obtuse angles. In Greek, this would be called orthogonia, this would be called oxyagonia, and this would be called amblygonia. That's enough about angles. That's the three types of angles. Let's move on to triangles. Triangles are shapes that are made by three sides, 1, 2, 3, and three angles, 1, 2, 3. Hence the name triangles. Three angles. Triangles can be separated based on either their sides or their angles. First, based on their angles, we have the right angle triangle, which has one angle, specifically this one, being a right angle. That means that it is 90 degrees. What you have to keep in mind about triangles, and this is all of them, not just right angles, is that the sum of their angles also always needs to be 180. Can't be less, can't be more, always has to be 180. So if I say that this angle, for example, is 20, and I want to find how much this angle is here, what I have to think is that, well, if I add them all together, 90 plus 20 plus whatever that last angle is, they all have to make 180. Well, 90 and 20 makes 110. 110 plus what makes 180? 110 plus 70 makes 180. So this angle would have to be 70. And that's how I find angles in all sorts of triangles. After the right triangle, sorry. Let's write that down actually so that we can remember that. The right triangle, we have the acute triangle. Let's also write that down. The acute triangle has 3 acute angles. That means that all of its angles are less than 90 degrees. As you can see here, they are all less than 90 degrees, and obviously they are not obtuse. Lastly, I have the obtuse triangle. This triangle has one angle that is, well, as the name suggests, obtuse, meaning that it is more than 90 degrees. It is big. And so here you have the 3 types of triangles based on their angles. A right triangle in Greek is orthogonio, acute triangle is oxygonio, and obtuse triangle is omblygonio. Next, we can also separate them based on the relationships between their sides. So I can have an equilateral triangle. This kind of triangle has all of its sides equal. So this side is the same as this side is the same as this side. And all of its angles also need to be 60 degrees, all of them. If you were to categorize it based on its angle, well, since they're 60, they're all less than 90, so that would make it an acute triangle if we were to name it based on its angles. But here we're talking about how we name it based on its sides. Based on its sides, this is an equilateral triangle. In Greek, that would be isoplevro. Next case, I have an isosceles triangle. This kind of triangle has 2 sides equal, but not the third one. The third one, as you can see, is smaller than the other 2. And also, it has the angles that are facing its equal sides. So this angle is facing this side, and this angle is facing this side. These 2 angles are also equal. And again, this is an isosceles triangle. In Greek, that would be isosceles. Lastly, the last kind of triangle has no sides equal. It can be one really big, one less so, and one even smaller. And this is what I would call a scalene triangle. In Greek, skalino. And the property of this triangle is that it has no sides equal. What we can't say about its angles, they can be acute or obtuse. We can't really say about its angles. But what we do know about a scalene triangle is that it has no sides equal. And that's about it about triangles. You should keep in mind always that the sum of the angles needs to be 180. So I hope you have a good weekend and see you on Monday.